So the notes I gave you, they are about ANOVA. And ANOVA is what you get when you solve regression using computers. That is the simple definition that I want to give you. And in what you wrote, you can see we have what we call the one-way, the two-way, the many ways, the maneuver, and so on. But for today, I want just to focus on how to interpret that table. And if you look at question number 1 in that handout, the question reads like this. You are examining the results. You are examining the results of a regression estimation that attempts to explain the unit sales growth of a business you are researching. The analysis of variance output for the regression is given in the table below. The regression was based on 5 observations. So we have that ANOVA, and that is what we want to discuss. So point number 1, there is something that is written here. You can see it. Now DF means degrees of freedom. Degrees of freedom. When you see DF, it means degrees of freedom. Point number 2, you can see the word regression. Now, regression DF, where the word regression meets column DF, that represents number of independent variables. Number of independent variables. Number of independent variables. The regression DF is the number of independent variables. And what is there? Regression DF, where they meet, who is there? 1. Good. We have 1. So that tells you, when you know the number of independent variables, you can be able to know the format of the equation that you're dealing with. You can be able to know the format of the equation. And we say the equation will be y is equals to a plus bx. If you are dealing with 1, if you are dealing with 1 independent variable, 1 independent variable. Then the other thing that you can be able to know is k. When we covered standard error of estimates, I told you k represents the computed values. The computed values. And the computed is A and B. So k here is what? Is 2. K is 2. Point number 3. Point number 3 is residual DF. Residual DF. Now, residual DF is given as n minus k. N minus k. And where do we have residual DF, Who is there? We have 3. So based on that, we are able to say that n minus 2 is equal to 3, and therefore n should be 3 plus 2, which is equal to what? 5. Which is equal to 5. So we are in the know that you can also get, you can get n like that, and get n like that. The next thing is called total BF. Now total BF is given as regression DF. Regression, the short form of the word regression is RG. I hope you remember this in the calc. RG. So regression DF plus residual DF plus residual DF. So this one is 1 plus 3, and the answer is what? Is 4. The answer is 4. Point, or before we move out of that, you say alternatively, total DF is equal to n minus 1, which is equals to 4. N minus 1, which is equals to 4. So sasa, you can be able to say that n will be equal to 4 plus 1, which is 5. Which is 5. Point number 5. You can see somewhere they have written SS. Is it? Now, if you can see it, that is the abbreviation of the word sum of squares. That represents sum of squares. Sum of squares. That's why this method is also known as ordinary least squares method. And this one, when we are in general statistics, it is what we call variance. It is what we call variance. It is also what we call variation. It is what we call variation. And some people also call it error. Some people call it error. Some people will call it error. Point number 6. There is the regression SS. Regression SS. Now, regression SS, it is what in the notes we have been calling explained variation. Explained variation. And this explained variation, it is given as what in your table? Mahali, the one regression, tumepatana na column SS. 88. 88. Then, point number 7 is residual SS. Residual SS is what we have been calling unexplained variation. Unexplained variation. Unexplained variation. So, unexplained variation in your table, it is given as what? 7.2. Good. 7.2. Point number 8. It is the total SS. Now, total SS is called total variation. Is called total variation. Total variation. And this total variation is given as the regression SS plus residual SS. And this one, if you took 88 and added to 7.2, the answer will be 95.2, which is the one that is given down there as total SS. Is that so? Good. Now, at this juncture, go to your notes and tell me the formula of SE. The standard error of estimate. The standard error of estimate. Unexplained variation of degrees of freedom. Now, ukiangalia hapo chini, when we gave the issues, the degrees of freedom were computed as n minus, let me see that, n minus k. Mahali umesoma hiyo, umesoma unexplained variation of degrees of freedom. The next thing that follows is the sum of whatever. The denominator is, do we have n minus k? So these are the residual degrees. And then we know the unexplained variation, 7.2. So the standard error of estimate, you will say it is 7.2. You divide by 3, and the answer you get the square root. So do that and give me the answer. $1.54. I'll take that to you. 1.54. The next thing, I want you to go to your notes and tell me what is the formula of R squared. The coefficient of determination. Unexplained variation. Yeah, it is the explained variation of a total variation. So the explained variation, we already know it is what? 8. And the total variation is 95.2. You can multiply by 100 or you can leave it that way. Give me as a ratio. .92. 0.92. Go back to your notes and tell me what is the formula of R, the correlation coefficient. The correlation coefficient. It's the square root of R squared. So you will take this 0.92, you get the square root of it. The 0.92, you get the square root of it. .96. So those are the values you can compute using those items. Now, point number 9. Point number 9 is MSS. Can you see it? MSS is an abbreviation for the words mean sum of squares. Mean sum of squares. And this mean sum of squares is given as SS, you divide by DF. You divide by DF. You divide by DF. So consequently, point number 10 is if you are looking for the regression mean sum of squares, regression mean sum of squares, it will be the regression sum of squares you divide by regression DF, regression sum of squares you divide by regression DF, and we already know regression SS is what? Is 88. We know the regression DF is 1, and you get 88. Is it the one given in the paper? Good. Point number 11 is residual mean sum of squares is residual SS. Residual SS you divide by residual DF. You divide by residual DF. So the residual SS, we already know it is 7.2. You divide by what? 3. The residual DF, there are 3. So the answer is 2.4. Is it the one provided there? Yes. Point number 12 is you can see somewhere they have written F. Now that F that is written there is what in our notes we have been calling F calculated. It is F calculated, and if you are told to compute it, it is given as regression mean sum of squares. You divide by residual mean sum of squares. Residual mean sum of squares. Sasa, this changes to regression mean sum of squares is 88. You divide by 2.4, and the answer is what? That is 6.667. Is it the one that is given there? Good. All right. Next point is what is written as SIG. SIG. Some softwares just give it as SIG, SIG. But some others, like the one we have as of now, it gives you the full figure, the full word, significance F, and this significance F, it is what in our notes we call F critical. It is what we call F critical. And this one, we are given that it is 0.009. 0.00904. If you look at that table now, have we mentioned or have we explained each and every figure? Yeah. Now, there are 2 types of questions the examiner can present to you regarding a number. The first type is where you are told to interpret one of these values. Unaulizwa inaonyesha nini? Na tumekuwa tukisoma those things. Ukiulizwa kitu kama R square inaonyesha nini? Already we have the notes. R, SE, EZDF. Yeah, that's the first kind of question. The second type of questions that you will get here is where they have given you missing values, or they have presented missing values and they want you to find them out. How you find is by knowing the relationship that exists between what is present and what is absent. Looking at these workings, most of them, they are a relationship of threes. These are 3 values. There is 88, 2.4, and 36. So you will be given any 2 of these after we will be given. Any 2, look for the other. Even this one is a relationship of 3. Something like this one is also a relationship of 3. This one is also a relationship of 3. After these ones. So you will have been given 2, you look for that one. Or you have been given some, you look for some others. So how you get those which are missing is by understanding the relationship that exists between what is present and what is absent. Because those who are online, are you okay? If you are okay, type yes. Yes, Catherine, okay. Brian, okay. Faiza, okay. Quinta, okay. Who has not responded? Yeah, Barbara, okay. Okay, good, good. The next item that I want us to mention is called interpretation of estimates through coefficients, estimates through coefficients table. So there's another table. Hii swali yenye tuko nayo haina hiyo table, but we are going to come across it in a while. Inaitwa table of estimates ama table of coefficients. So point number one, andika the column of details, the column of details contain the word intercepts all, just a minute. So we were saying contain the word intercept or constant and names or representatives of the independent variables of the independent variables Point number 2. The column immediately after the column of details contain or contains solutions or coefficients. Solutions or coefficients of the equation which all together are known as slopes. Point number 3. When you see standard error, it represents as B. It is the standard error of the slope. Number 4, when you see T, it is what we call T calculated, which we know so well is given as B, you divide by SP. Number 5, if you see sig or significance T, it is the plus or minus T critical. It is the plus or minus T critical. Number 6, if you see limits or interval, you use the formula we came across, tukasema ni B plus or minus T, 1 minus alpha out of 2, N minus 1 multiplied by SP. Multiplied by SP. So those are the other very, very important points that you need to know for you to interpret that table. So with that, now we can start answering the questions. So we answer question 1 now. So we can take a solution 1. Now that we know the table, we can answer the questions. So the first question is, how many dependent variables are in the regression to which the ANOVA refers? How many dependent variables do you have in that table? Yes, Brian. Good. I can see 1. See 1? Yes, we mentioned about it. Good. Part B. Define total SS. We have said total SS refers to what? It is? Read in full the way we have written. Say you read in full the way I have given. Total SS is equal to? Yes. You can give us total variation, or you can call it total sum of squares. You don't just say sum of squares. That's a different thing. Number C, or item C, calculate sample variance of the dependent variable using the information. So variance, we have mentioned variance somewhere. Is that so? Where did we mention the word variance? SS. Now, SS is the variance, and when you're told to deal with the sample or to give us for the sample, you go for the total. So this is the total SS, which is 95 point what? 0.2. You give the total. Part D, define regression SS. Regression SS, we have said it is called who? Explained variation. Great. Explained variation. Explained variation. And then we are told, explain how its value of 88 is obtained in terms of the others. So how can we get 88 in terms of the others? Yes. How can we get it? You take 95 points minus 7.2. You get 88. Very simple and direct like that. What hypothesis does F test? I want you to go to where we covered F. And one of the easiest ways of understanding these things is by being fully obedient of the instructions that come your way. So when I tell you to read kwa sauti ya kisha unasoma, hata wenye mko nyumbani, ensure you read kwa sauti. It is one of the easiest ways of getting these things very fast. So I have said you go to where we covered F. Are you there? Now, if you are there, there is the first statement that says that this is used to test what? When you go out. These are F tests. F tests. Are you there now? So if you are there, let's read. It is good. Used to determine significance of the relationship. So when they ask you what hypothesis does F test, you simply tell them it is significance of the relationship. 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 Part F. Explain how the value of F statistic of that 6 is obtained. That one we already know that it is F calculated, which we have said it is obtained by getting 88. You divide by 2.4, and that gave us that 6.67. Pfizer, I did not see your comment, but I hope it was talking about the variance, which is okay. You don't see it on time. Is the F test significant at 5%? Right. Let's go back to the F test. Let's go back to F tests. If you are there, we said and we have just read that it is used to test what? Significance of the relationship. And that is done by taking those steps. The first step, we call it hypothesis. And in the hypothesis, the null hypothesis is the relationship is not significant. The alternative ikasema the relationship is significant. Then we went to step number 2, which was significance level. We have the answer there. Then we went to step number 3 called what? Test statistic, and we computed something there called what? F calculated. And what was the answer? 14.2. Then after that, we took another step called decision rule. And in the decision rule, we drew a diagram that is divided into how many sides? There are 2 sides. There are 2 sides. What is on the left-hand side? What have we written on the left-hand side? Accept the null. And on the right-hand side, what is written? You reject. And the borderline below it tumeandika F critical, or just F. And we gave the value there. What value did we read from the table? The value that is there. Why you 5 points? Yes, that is what we call the critical. Then after that, we went to the next step, which is called conclusion. And what did we say? We reject the null because F calculated was what? Greater than. So how many values did we require for us to make the conclusion? 2. The first one is the name. The calculated, and the second one is what? Critical. So you require 2 values for you to make the conclusion. The calculated and the critical. So that's the first thing you need to understand as we answer this question. That we must know what is calculated, and we must also know what is what? Critical. Ndio tutarudi hapo juu, we make the conclusion or we decide. Why did we say we reject? No. In the conclusion, tumesema we reject. Since F calculated was what? Was greater. What did that mean? The relationship? The relationship between the ages of the husband and wife was what? Significant. So ukishaelewa hiyo kitu vizuri, now you can comfortably answer this question. Let's come back here. Tumesema we require how many things? 2. Ya kwanza ni F calculated. Do we know it? So naanzia hapa unasema F calculated is that 6.667. Who next do we require? F critical. Do we know it? Yes. What is it? 0.00904. Good. So what do we say? Is it in the region of accepting or rejecting? Ukifananisha na hiyo rule that we have drawn, we will reject. And when we reject, tukienda kwa meaning, tutasema it is significant. So the question was asking you, is F significant? What is the answer? Yes. The answer is yes, since that 6.667 is greater than 0.00904. Tunaona hiyo maneno yote tuliandika hapo kwa f-test, kutoka hypothesis mpaka meaning, you can summarize it this way. Hiyo. You can summarize it that way. See hapa tuko sawa? Haya. Let's proceed to the next question. We'll start it for us. Question 2.
Question 2. Outline the assumptions of the linear regression model.
Okay, great. Part B.
Part B. A mortgage company intends to develop a model to be used to predict the number of loans issued by the company. The company has collected data on the number of loans issued by the company over a 10-year period. The data has been processed using computer software and the following results generated. Variable entered, stroke removed, bracket into bracket B. Model 1, variable entered, year, interest rate, income, A. Variable removed. A. All requested variable entered. B. Dependent variable loans. Model summary. We have model 1.
Some of the figures. Hata hapo umefika inatosha. Thank you. Thank you. Now you can see the tables that follow there. There is the table that is ANOVA. First of all, kuna hiyo model summary. Model summary iko na kina R, iko na R square, iko na adjusted R square. Adjusted R square, that one is not in your syllabus. That's why I did not teach you. Then the standard error of estimate. Now those values in your own time, you will confirm whether that's how they are computed. Ukitumia, naona the second table that is written ANOVA P. It's only that the typo did not come out well. ANOVA is the title of the second table. Naiona, which has the first column in a soma mode 1. That should have been model 1, or rather, that should have been model, not mode 1. Even your column ilikuwa squeezed. Umeelewa hiyo model, Then the second column haina name. Then we have the sum of squares. On the other side software you the full name. Yeah. Then we have the DF, we have the mean square, we have F, and we have C. So you need ANOVA to interpret for the other question. Then we have the next table that is titled coefficients. The table that is titled coefficients. And you can see again the first column should read model. The second column haina title. The next one is standardized coefficients. The typo there was not done well. Inastahili kuwa namna hii. Inastahili kuwa namna hii. Inastahili kuwa. So hapa juu kuna hizo unstandardized coefficients. Tunaona hiyo. Then hiyo space ingine imebaki hapo. It was meant to be slope na hii error. So that in the column of the throw, the first item to appear is X, and in the column of error, it is 25,478. So tengeneza hivyo ndio ikiwe sawa 478.477. Ifaa kugawanywa column ya kwanza ikuwe slope, hiyo nyingine ikuwe error. So add hiyo. And then you can see there is the standardized coefficients. Then kuna T na kuna C. So the first question is, you get the values represented by letters H, Y, and Z. So those values, they are in the table of coefficients. So let's now get the solutions. So solution 2. So number 1, is missing values. Missing values in the table of coefficients. In the table of coefficients. Missing values in the table of coefficients. When you are in the table of coefficients and you find anything missing, it is one of these three. T calculated being equal to B out of SB. If you are in the table of coefficients, now kuna kitu that is missing, most likely it is one of these three. Either T calculated, SB, ama B. So sasa, what you need to know, it is that which is missing is which one here. So tuanze na X. Who is X in these three? Is it T calculated? Is it B? Is it SB? B, good, is the slope. So if it is B, can you make B the subject of this formula? It will be SB, you multiply by T calculated. You multiply by B calculated. So B is the SB. Yeah? The SB is 25,478.477 times T calculated. T calculated is minus 0.125. What is the answer? 3184.18. Another 0.81. Namna hiyo. Okay. Yule mwingine amekosekana is 1. So who is Y among these three? It is T calculated. Great. And if it is T calculated, we know This is B out of SB. And we know B in Y is minus 1683.706. You divide by the SB, which is 885. 885.742. -1.9, -1.9. I will figure out 3 decimals because this table is designed to 3 decimals. 0.1. 0.1. Give me a 0.1.9, no harm. But it's always advisable to go with the number of decimals already presented. Haya, twende kwa Z. Z is who? SB. So how do you get SB? What are the, yeah, how do you get SB in this formula? It will be B over T calculated. So B is minus 372.291. You divide that by T calculated, which is minus 0.444. Three decimals. 838.493. The next thing, we are told to tell the model. Remember, model is the other word for equation. Let me introduce that. It is the other word for equation or function. Unaona kwa hii swali, the computer was using the word model. The one I was telling you, the column was not adjusted enough. So for you to know the model, you must first of all know number of independent variables. Number of independent variables. So how many independent variables are there in that question? I told you how to look for number of independent variables. That was the points I gave you. Who shows the number of independent variables? The regression? Yeah, after regression, DF. It is D. Good. Catherine, you are talking of 3 or 2. It is 3. Hope you have gotten that. The regression DF. Na unaona hapo juu kuna mahali wameandika variables enter. Kwa hiyo swali. Na mahali umeona variables enter. Ya kwanza ni Here, then income. So there are three. There are three. Then, before that, Agaria I have given you points of interpreting a table of coefficients. The first point tumesema, the column of details contain the word intercept or constant and names of or representatives of independent variables. Sasa hii table yenye tuko nayo, can you see the second column? The table of coefficients. Can you see it? Now, if you can see it, first of all, haina jina, haina title details, na si lazima iwekwe. Because we expect you ujue, mahali tumesema details ni maneno. Let me put it that way. Can you see hiyo column iko na maneno? Words. Yes or no? Simply say yes or no to something. Huh? I'm saying, are you in the table of coefficients?
Yes.
Kuna column ya kwanza imeandikwa model, si ndio? Kuna column nyingine haina title. Can you see it?
Yes.
Yes. Na ndio nimesema si lazima iwekwe title. Because what is in that column is what we call details. Details ni particulars, ni descriptions, ni words. Sasa hapo ndio nilikuwa nakuuliza, unaona column iko na maneno? Yes. So the first name ni constant. The next one is? The next one? The next one? Does it contain what you have said it should be contained? Yes. And those three names that you unaona hapo, are they the variables that I entered up there? Mahali umesoma variables entered? Yes. So let's come back here. Now that we know that we have three independent variables, we are in a position to know the format. Our equation will be y is equals to a b1x1 plus b2x2 plus b3x3. So hiyo unajua. Then burudi hapo kwa points of interpretation of the table of coefficients. Point number 2, kusoma kwa sauti venye tumesema. Coefficients or solutions of them? Yes. So the column that is just next to it. Can you see that column? So that column, the value of A, which is the constant called intercept, it is x, which already we have determined is minus that 184.81 plus uchukue hiyo ingine 6772.23x1 minus 1683.706x2 minus 372.291x3. I hope you are able to see those figures elsewhere other than the whiteboard. Is that so? Are you able to see them elsewhere? Yes or no? Yeah. Also, other than your book, You can see them in the question paper. Yes. They are very simple. You just copy them that. The next question is the independent variable or variables if any that may not be useful in the predictor model, and explain your answer. Tuende mahali tulisoma t-tests. Sikuwa mahali tulisoma t-tests. T-tests. Are you there? T-tests. Mahali tulifanya hypothesis. So if you are there, nataka usome mwanzo niambie, it is used to test significance of the independent variables. Good. Sasa ukiambiwa usifunge hapo. Ukiulizwa which independent variable is not useful. Something that is useful is also something that is significant. Is that so? Yeah. If you are looking at that test, hypothesis, the null hypothesis is X is not a significant what? Predictor. The alternative tukasema X is significant determinant. Then tukaenda step 2, which is significance level. Tukaenda step 3, which is called what? Test. Tukaenda and in that to compute a value that we call what? T calculated. Then tukaenda step 4 called decision rule, and we drew a diagram which is divided into how many parts? 3 parts. On the left hand side, it is called what? Significant. At the middle, insignificant, and on the right, significant. Then there are 2 border points. There are 2 border points. One is negative and the other one is positive. See there? Toka hapo tukaenda kwa conclusion, which we said what? We reject because T calculated was greater than. And then in the meaning tukasema the age of the wife is what? Is significant. And at that point I reminded you that the word significant is the other word for reject. So if you look at the conclusion, how many values did we need to make that conclusion? 2. The first one is T calculated and the other one is T critical. So that tells you for us to answer this question, we must know those 2 values, the calculated and the critical. So hatutaipanga venye tulipanga hapo. I'm going to summarize it in a table here, but we are following namna hiyo venye iko kwa notes 2. So sasa andika hivi, independent not independent, I should have started with the significance. Significance of independent variables tests. So we will require the predictor. Predictor is the other word for what? For the determinant and also for independent variable. So you can either say independent variable, and the same determinant, you can also say predictor. Then tumesema we will require the value called T calculated. We will also require a value called plus or minus T critical. And then we will make the conclusion to judge whether it is significant or not significant. The first independent variable as zimepangwa hapo is income. And according to venye tumepanga hapa, income ndio x what? X1. Then interest rates, it is our x2. And then we have here, which is x3. Do we know the T calculated? Yes or no? Yes. For the first one, it is 1.006. Huyu mwingine ni minus 1.901. Na huyu ni minus 0.444. Do we know the critical? Yes or no? No. Okay. Go to where we interpreted the ANOVA. Go to where the points I gave you of the ANOVA interpretation. And that should be point number 13. So is the answer yes or no? Yes. So if it is yes, it is plus or minus 0.353 plus or minus 0.106 plus or minus 0.673. Those values are given. Those values are given. So we want now to make the conclusion. And in making the conclusion, this is what we shall do. Go back to where we ended the t-test. T-test. Mahali tulikuwa tu tunasoma hizo hypotheses. If you are there, are you there now?
Yes.
If you are there, look at the test statistic. The calculated value is what? Yeah. Then look at decision rule. Negative, the negative t is 2.6. Now the positive is 2.6. Ndio. Sasa tuliwekelea hiyo 3 point something kwa hiyo decision rule. Ikapatikana on which side? Where is it found? Iko kwa region gani? Acha turudie tena. The calculated is 3.8. Let's just pick the first lesson. 3.8, sio? Haya, ukienda kwa rule, the negative is minus 2.26, eh? Negative 2.6, sio? And the positive is 2.2 or 2.2, right? Okay, 2.2. Sasa hiyo 3.8 ukiwekelea kwa hiyo rule iko side gani? Iko huko juu, si ndio? Na hiyo region ni significant. Si ndio? Yes. I want you now to imagine hii ndio iko hapo. Unaona hii? Ikuwe minus 0.3. Unaiona sasa iko kwa hiyo table. Na unaona positive 0.3. Haya, wekelea hii niambie wapi? Iko kwa insignificant. Watu wataelewa hiyo kitu. Turudie tena. Hiyo yenye unaona. Calculated is 3 point what? 3.8. Haya, negative ni kwa the rule Osman. The negative is what? Hapana. Tuko kwa hiyo yenye iko kwa kitabu. 2.2. And the positive is? Haya, weka hiyo 3.8. Utaipata wapi? Insignificant. Because it is smaller than 2.2. Unachanganya. No, I can see you. I can even see where your eyes are. Ziko kwa hapa. Hatuko hapa, hatuko kwa kitabu. Tunawekelea hiyo 3.8 na 2.2 na 2.2. Tunaanzia hapo. Tukishaelewa hiyo ndio tukuje kwa hii. Sawa? Haya, tuanze tena. Tuko na 3.8. Can you see it? Haya. On the negative it is minus 2.2, sio? And on the positive tuko na 2.2. Sasa nataka uwekelee hiyo 3.8. Iko side gani? Iko kwa significant. Yes. Those who are online, I hope you are following. Haya, sasa kama iko kwa significant, sasa nataka uachane na hiyo iko kwa kitabu. Uassume sasa ni hii na hii sawa. So hapo kwa negative ona hii. Na kwa positive uone hii. Uniambie hii 1.6 iko wapi? 1.06. Iko kwa? Good. Simple. Haya, wekelea hii nayo hapa. Minus 0.1 na positive 0.1. Hii iko wapi? Siko na huko chini. Haya. Wekelea hii nayo. 0.6 negative na 0.6 positive. Huyo atapatikana wapi? Inside. Very simple things, my friend. So that is how you can summarize the t-test. The next thing is advise the management on the suitability of the model. Anytime you see the word model, which I have said is the function, you should always go to F tests. You should always go to F tests. So I think suitability of the model. Suitability of the model is just being asked whether the relationship is significant or F is significant. That means whether you can remember what we had discussed earlier. When earlier on we came across swali ya F, tulisema we require two values. Ya kwanza inaitwa F calculated na huyo mwingine ni F critical. Good. Haya. Kwa hii equation or kwa hii table, tell me F calculated is what? In that table or in those tables, F calculated is. Ukisahau rudi kwa zile points zenye nilikupea uangalie F calculated inapatikana wapi. It is what? Yeah. 1154.865. Good. Hiyo ndio F calculated. Haya, huyo mwingine ni F critical. F critical. Now F critical, it is none. Umepewa what? 0.00. That is the critical. And because it is 0, it is there, it is 0. Higher. So what we say, the model is suitable. The model is suitable. Ukiulizwa why, unasema since F calculated is greater than F critical. That is 1154.865 is greater than 0.000. I hope bado tuko pamoja. Let me see your past papers. So these are the habits. Later on your own, you handle November 2016, question 2C. November 2016, question 2C. We need to submit the second question. I still have some few minutes to finish that. One illustration questions. No, that should be question 3. Question 3. Lakini hiyo ya past paper ndio kujipanga hapa ni kujipanga nayo. Tusomee the next one and don't read the figures, so we do the words.
The following regression equation was calculated for a class of equal to 2 students. While the students score on a table examination, X1 is students rank from the bottom in high school, X2 students global attitude score, X3 a measure of the student's character. Required calculate the T-ratio and the 94% confidence interval for each regression coefficient. B, what assumption we use in A above all reasonable and C, which regrets give the strongest evidence of being statistically understandable. D, in rating of opinion of the report should want to the first regressor in the history of it.
Thank you. That's good. That's good. So let's now quickly try to provide that. Solution 3. Solution 3. So in the solution 3, the first requirement is to get the T ratio. So tunaweza ipanga namna hii. We can use the word regressor, T ratio. So T ratio is given as B to divide by SB. This is the T ratio. And it is what we have been referring to as T. Good. T calculated. It's what we have been referring to as T calculated. It's what we have been referring to as T calculated. So there are 3 of them. So if there are 3 of them, tuanzie X1. The slope for X1 is 0.021. You divide by the standard error, which is 0.019. Give me the answer to 3 decimals. 1.105. We go to number 2. Number 2, the slope is 0.075. And this is 0.034. 2.206. H3 is 0.043. You divide by 0.018. Two point 389. So the next requirement is confidence interval. Confidence interval for the slopes. So again, we will have the regressor. We'll have the regressor. And we know the formula. The formula says you get B plus or minus T 1 minus alpha. Now, because we know alpha is 95%, amina is 5%, so tutaandika namna hii. You divide by 2 and n is 24. So the sample size is 24. Then you multiply by SB. You multiply by SB. Sasa tuanzie x1. X1, the slope is 0.021. Plus or minus. Now go to the tables. Go to the tables. Unisomee hii. The students' T tables. And this is 2 tables. It is 2 because we are dividing here by 2. Lakini kama hatungekuwa tunadivide it in 1. So you go to the 2 and 95. And sasa usimame kwa 23. Namna hiyo. Sasa times the standard error. The standard error is 0.019. You have to say 0.021 plus or minus. Give me this one to 3 decimals. This one to 3 decimals. Zero point 319. Okay. I subtract this one from this one. You have to the limit. Negative 0.016. 018. Now add it is 0.060. So kama hiyo iko sawa, unafunga hapo, tuende kwa x2. X2 we take the slope. The slope is 0.075. Plus or minus, this one remains 2.0687. 2.0687 multiplied by the error, which is 0.034. So 0.075 plus or minus, give me the answer again to read to 3 decimals. 0. Okay, then when you subtract, we are then left with 0.005. And then when you add, you are left with 0.145. Okay. So jifanyie x3 on your own. Sahi. Do x3 on your own. Haya, umemaliza eh? Aha, on the lower side ukapata 006. And on the upper side, haya. Hiyo ingine si assumptions unajua the 6 of them. See, I taught you the assumptions. The group demand to solve the regression assumptions. You look like these notes are not yours. When you become friends with your notes soon. Are you there? The first assumption to ita nini? Linearity assumption. Number 2, tukaita nani? 0 mean for the error terms. Number 3. Then number 4, independence of normality. Normality. Number 5 is, and the last one is independence of the, on the very basic solution. In answering this question, it is to state those assumptions. Utaje tu majina ya hizo assumptions. Kikuremea kutoka hapo hiyo. But kama umezielewa, now you can be able to tell whether it has applied here or it has not applied. By mentioning, yes, that's good enough. This is not a grammar paper, it's computation. So your theory, we are not so keen. Bora unaonekana uko na idea, unajua hizo assumptions. But I'm not saying usimamie tu hapo kwa idea. If possible, you can explain to us. But I'm saying in the worst case scenario, just take the assumption. The next one, tunaulizwa which regressor gives the strongest evidence of being statistically discernible. Now that one, you can simply answer by looking at this one. How is it calculated? Yule hapo juu sana. The highest T calculated here is the strongest. So you can answer without doing the T-test. But because I still wanted to know how to do the significance, I want to do it again. But I'm saying, hiyo swali nikejibu ukiangalia hapa. Nani yako the highest? Yes. So this is strongest. Ifuatwa na huyu the weakest. Strongest as in kama boundary ilikuwa imewekwa hapa. Like the way customer wamekuwekea boundary ya 50%. Na mmoja ako na 50% ama 51. Na kuna mwingine ako na 80. Who is the strongest? Mwenye amesonga past the boundary. So just to cement our understanding on how to do the significance tests, nataka tutengeneze hiyo kameza hapa. Significant of independent. Actually, it's not even avoidable because we must, it is required for us to say whether we are dropping or not dropping. Independent variables. So, to an ingressor, we require T calculated plus or minus T critical, and then the conclusion or the comments. So x1, x2, x3. The calculated we have 1.105, 2.206, 2.389. Critical heat is so much. This is a critical. The one that you read from the table. So plus or minus 2.0687. Plus or minus 2.0687, plus or minus 2.0687. Let's start. Asia. Can see your smile. Is this significant or insignificant? It is? Insignificant. Good. Insignificant. The second one, it is significant. Good. And you are now flowing with the card. Then the next one. It is also significant. Good. They are very simple things. So now borderline ni 2.0. So when you repeat zaidi, so we do the strongest. And the last question was, should we drop the first one? The answer is yes. Why? It is what? Yeah, it is significant. Anything or anyone who is significant in your life, you drop. As in outside D. But you drop in a wise way. You don't drop in a way that it is easily notable. Because you never know whether tomorrow may be useful. Sasa naona time imesonga sana, but with those questions, you should be able to handle the others. I think I told you how you should approach, or you should be approaching the assignments. You are supposed to sasa uende mfunge kitabu. Hiyo maswali yenye tumejibu pamoja, ujaribu kujifanyia. Ukikwama, unafungua kitabu na angalia, tena unafunga. Until ujibu hii swali kutoka mwanzo mpaka mwisho. If you are able to do that on your own, utakuwa umeelewa hiyo swali. After that, sasa weka kwa assignment. Lakini tukiachana tu saa hii, uende the next assignment, you will see stars. Alafu before you know it, tuanze kusema huyo mwalimu hii QA. Mwalimu na QA hawana shida. Wewe ndio umetumia the wrong approach. Na ukishindwa kujifanyia kabisa hii tumefanya, you stop there. Next time ukiniona ama ukimpata kwa mitandao ama wherever, uniulize. But don't attempt an assignment kama hujajifanyia yenye tumefanya pamoja. Then you solve the assignment and if you already have done this, when ninasema na bado assignment kuremee, I have given a solution. Unigoje ama unitafute. I'm available physically or internet, if there is a word like that. Or one of the ways of kunitafuta, which I recommend, is sasa ulete hiyo assignment yenye umeattempt mahali umekwama, ulete. Yeah. You bring the physical book, you drop it there, I'll mark. Or you send kwa mitandao, like Catherine does that. Catherine huwa anatuma. At times she even calls me and I give the answer. Yeah. So you should not struggle with the problem alone, but hakikisha umefuata the right procedure. Yeah. Either uandike, upige simu, when we are available, you make him understand is what? You make him understand is sasa, by all that, simply saying hiyo maswali tatu imebaki kujipange nayo, because that marks the end of that topic, at least for now. So we have the next topic called time series, and what I'm going to do is to give you the notes. They are just 2 or 3 pages. You copy them. And then when we meet next, we will basically actually hata tunaweza discuss in 2-3 minutes. Time series is data that has been gathered over time. Imepangwa Monday tulipata hii, Tuesday tukapata hii, Wednesday tukapata hii. That's what we call time series. And then it has 4 components. Kuna moja inaitwa secular, ingine inaitwa seasonal, ingine inaitwa erratic, ingine inaitwa cyclical, and we'll be computing them. Then there are methods of fitting thread. Moja inaitwa freehand, ingine semi-average, ingine moving averages, ingine ni ordinary least square. Ordinary least square ni maneno tunafanya. Hii tunafanya tu regression. Forecasting, we use the semi-averages, moving averages, regression, method tunafanya. Then exponential smoothing, and then the models. So I think even that, maybe it is a very simple thing. So when we meet, after you have copied these notes, I will do, there are 3 main areas that are examinable as far as this topic is concerned. Just 3 main areas. So ndio tutajibu maswali. So that by next week, we should be done with this. In the next 2 weeks, I should be through with this syllabus. So for those who are online, I'm sending you the notes right away. Make sure you copy them, look at them. Then when we meet next time, we will discuss and proceed. Thank you so much. Have a great weekend. Oh, Quinta, you are asking of any update on the new syllabus? Allow me to comment on that, maybe next lesson, because there are also several things I'm not understanding, and I am booked to see some officers of council next week to clarify. One of the issues is whether nyinyi mkienda set 5 unafanya EFR mara mbili. EFR, because EFR in equal 6, it has been brought to 5. Now wanasema nyinyi mtafanya the old syllabus. So I want to know whether mtafanya EFR set 5 na mtafanya set 6. So allow me to comment then. Thank you.